What is subnetting? So when we talk about IPv4 addressing, so with IPv4 addressing, with growing number of devices, so it is getting limited. So as we know that IPv4, IPv4 is 32 bits and 2 to the power of 32, which gives us 4.3 billion IPv4 addresses. So only 4.3 billion of IP addresses are being there. So in that case, what will happen is we are in very limited scope of it. So this is what and how we can conserve this, and based on this conservation, which all methods are there, how we can do subnetting. So we will able to see this in this lecture. So summary for the previous lectures was, we started with the physical address and logical address. So physical address is referred to the MAC addresses. Logical address is basically IPv4 address, IPv6 address. Then we started with what is the private addressing and what is public address. So that is belongs to IPv4. After completion of private and public address, we'll able to see that what is IPv4 address assigned to the PC based on what? Based on doing an IP config. And then what is the subnet mask and what is the default gateway. And converting IPv4 address to decimal notation to a binary notation. So based on this decimal notation that we got from the command prompt from ipconfig, and then we convert that to a binary notation. This is what we covered so far in our addressing with computer networks. So today we will be covering about the subnetting. So why we need subnetting? Basically, we need subnetting to conserve the IP address, use a network efficiently. So efficiently means how we can assign the IP addresses to the host using subnetting, and which will be an efficient use of it. When we talk about IPv4 address, and we know that 4.3 billions of IPv4 address exists. With 4.3 billion of IP address, this is what a limited number of IP address with the number of devices that is growing in terms of IoT, in terms of your mobile, in terms of your laptop. So what are the ways in which we can conserve the IPv4 address? The first way is CIDR. So what is this CIDR stands for? CIDR is Classless Inter-Domain Routing. The second is doing a NAT, Network Address Translation. So network address translation is basically from a LAN environment, what you assign a private IP range. So NAT is, you will translate this private IP into what? A public IP address. So mapping of a range to a single public IP, you can do that. You can do PAT. Many things are there. We'll discuss this in our upcoming videos. Using private IP address. So that also conserves our IP address space. What is the fourth one? We can go to IPv6 transition. We can do IPv6 transition. That means IPv4 to IPv6. That is what nowadays everyone is doing it. The fifth one is basically IP address reclamation. So what is this? This is basically being used to process the unused IP addresses are there by allowing the DHCP lease. So we will see this one in our DHCP chapter. Based on the lecture for today, we will focus on this part, which is called as CIDR, Classless Inter-Domain Routing. What is CIDR? CIDR, Classless Inter-Domain Routing. This is a method to allocate IP address more efficiently. So what do you mean by more efficiently? We'll see that. With classless inter-domain, we will use VLSM, another concept. That means what is VLSM stands for is Variable Length Subnet Mask. So what is this one? What is VLSM? So what is VLSM? So VLSM allows a network to divide in smaller networks, or you can say that it will divide into smaller subnets. Why we need to divide in smaller subnet? Why we need to divide a network in smaller subnet? For instance, you will have an IP address 192.168.1.0/2. In this IP address, this is my network and this is my host portion of it. In total, we can assign 256 IP addresses from this range. So out of that, one will be the network, one will be the broadcast. 254 IP address can be assigned from this. Think about a network. For example, you have a network of 10 hosts. So when we have a network of 10 hosts, so do you think that this subnet, if I use this in this network, is this an efficient way to assigning an IP address space to this only 10 host? The answer is no. We cannot. We can assign, but it is not an efficient way to assign this /24 address to this network where we will have only 10 hosts. Coming back to Variable-Length Subnet Mask, VLSM, it will divide a network into small networks, or it will divide a network into small subnets in which your IP address assignment will be efficient. Using a VLSM technique, you will assign IP addresses much efficiently. So when we talk about CIDR is basically an IP addressing that allow more flexible and efficient use of your address space. So this is what CIDR is. It also allows VLSM to divide the network, a big network, into what? Smaller subnets, or you can say that smaller networks. So VLSM also helps to reduce your routing table. So how we can correlate our CIDR and VLSM concept to our real life scenarios? Think of a real estate, right? So a real estate developer is there and which is having a big piece of land, and then what it does is it divides in plots to sell it. So it will divide the plots 1, 2, 3, 4, 5, 6 equal size plots to sell it, right? Is this an efficient way to do it? For example, person ABC wants a smaller plot, not the big one. Or person XYZ wants a big plot in which he wants to create a big house. In that case, this is not an optimum way to do it. What will be the optimum way to do it? So the optimum way to do it is we can have mix of plots. For example, smaller one, we will have medium smaller one and a big one as well. So what that means is if anyone wants a small plot, he can buy it. ABC wants a small plot, he can buy it. XYZ wants a bigger plot, he also can buy. And this is the way in which it will able to assign each and every individual whosoever wants the plot in based on their need will efficient way to do a plotting. Doing it equal size, when ABC wants a smaller one, XYZ wants a bigger one, then this is not an efficient way. Similarly, using the concept of VLSM, what we can do, we can have the plot small plots, medium-sized plots, and with a large plot as well. So in which the requirement for XYZ is also fulfilled. ABC requirement is also fulfilled. Anyone, for example, DEF wants to have a medium-sized plot, that is also fulfilled. So this is what we refer to as an efficient way to do it. That efficient way is what we can refer in our case is variable-length subnet mask. Using this technique, using this concept of VLSM, CIDR basically allows to divide the big network into smaller subnets. So this is what it provides, a granular way to assign an IP address space as per the need. Basically, the IP address space as per the need, we can have variable sizes based on the number of hosts in the LAN network. So another example is, if you think when a chef is preparing a meal for a large party, right? He needs variety of ingredients. Based on this ingredients, if you look at it, we need some portion of this. We need small portion of these things. And we need another small portion of, you can think of a salt, right? So measuring each and every portion of it is important to cook for a quality dish, right? Similarly, when we talk about VLSM allocates IP addresses in such a way that it will do a granular approach, and whatever is needed based on what? Based on the number of hosts that is being there, it will assign those IP address to that. So when we talk about IP address allocation, so IP address allocation divide in two parts. One is classful, the other one is classless. When we talk about classful, these IP addresses range are divided in classes. So we have class A, B, C, D, and E. We have different classes for this. And just remember that VLSM is not supported with the classful addressing. So what will happen if VLSM is not supported? Then it is an inefficient way. So it's an inefficient way by which we cannot assign smaller subnets as per the need. So at the same time, when we talk about classless addressing supports VLSM. So if it supports VLSM, then we can go up to the smaller subnets as per the requirement. So if it is VLSM, we are doing an efficient way of assigning what? IP address. So in this case, the CIDR is used to specify the subnet mask. And based on the subnet mask, we know that, which indicates the network space and which indicates the host space of it. So based on this classful address, so it been divided in what? It been divided in class A, class B, class C, D, E. So it is divided in different classes. In order to understand different classes, first we need to what? We need to create this subnet. In order to understand the classless and which class, what is this class means, we need to create that same 32 bits field. So this 32 bit is being converted to this bits, right? 32 bits, 4 octets, 1 octet, 8 bits. So we have 4 and 4, 8 bits. So when we think about class A, so class A identify as the first portion of it, the 8 bits that has been there, is the network part. Remaining 24 bits are what is the host part of it. So for class A, if I write down the subnet mask, what it will be? it will be 255.0.0.0. Means why 255? Because the first octet is all ones. If it is all ones, then we will have 255. From this, what is the CIDR notation? So CIDR notation will be /8, because for the we always consider the network part of it in the CIDR. So which is /8, which can be represented in a subnet mask like this, 255.0.0.0. /8 means all the 8 bits turned on. From this, how we can calculate the host part of it? The host part is basically what contains 8 is there for your CIDR for your network. Remaining is what left is 24. So 24 bits are there for your host. If we do 2 to the power of 24, it will give us 16 million IP address. 16 million IP addresses for host portion of it. So from the network part, what will be the network addresses from this? For class A network, we can assign what? We can assign basically 1 to 126 usable host. So this is, to assign the network. So we know that we will have 16 million IP address range being available for host, which we can assign to individual devices. But what will be the network in that case? So the network range will be 1 to 126. Why 1 to 126? Why not 127? The reason why 127 is not there, because 127.x.x.x will be used for loopback testing, or which has been assigned to NIC card. This is a reserve IP address. So for class A, basically we will be able to assign 1 to 126 range. So what is class B then? So class A, we have 8 bits on for the network, 24 bits on for the host part of it. With class B, we will have 16 bits assigned to what? Assigned to network. We have 16 bits which will be assigned to network, and we will have 16 leftover bits which being assigned to your host. So if all the bits turn on from this 2 octet, then it comes to 16 bits. If everything is 0, then it comes with 16 bits. Now, what is the subnet mask? So for this, the subnet mask is what? 255. Second octet also 255. Third, fourth octet is 0.0. The CIDR notation for this will be /16. Only first 2 octets are turned on. What will be the host portion of it? The host portion is what? 16 bits that has been left. So 2 to the power of 16, which will give us 65535. So what is 2 to the power of 16? So total number of hosts 65536. So total number of hosts in class B will be 65536. What will be the network address from this? Which all ranges from this network address? So the network address starts from 128, because we left it here with 127, to 191. This is the network address range from 128 to 191, because the 16 bits is there for what? The network. So if the 16 bit is there for the network, 2 bits are always being used as 10. So 14 bit is left. 2 to the power of 14, we can create up to 16384 networks. So how many networks that we can create in this? We can create 16384, range from 128 to 191. That is what the first 2 octets tell us. So we discuss about class A, we discuss about class B. Now what is class C? So when we talk about class C network, the network part is what increased by another 8 bits, which is now 24 bits for the network. And the host part of it is now what? 8 bits left. This is my host part. So what is the subnet mask now? Subnet mask for class C. So subnet mask for class C 255.255.255.0. 888. So 255, 255, 255, and 0 is the host part. So in total, what if I talk about CIDR? CIDR is now what? /24. So 24 bits will be there. 2 to the power of 24. But in order to assign in the network, the first 3 bits. So like in class A, we took first bit. Class B, we took first and second. In class C, we will take first 3 bits. So in total, it will be 2 to the power of 21. 2 to the power of 21, which will give us 21 millions network. So 2 to the power of 21 gives us 2 million networks, wherein in the host part of it, it will be 2 to the power of 8. So 2 to the power of 8, 1 will go with the network and 1 will go with the broadcast, and remaining is 254. That we know that it is 256. So 2 to the power of 8 is 256. What will be the range of this 2 million networks will be? The range of this 2 million networks will start from where? 192. Okay, it will start from 192 to 223. This is the class C address. So the class D address starts from 224 up to 239. So this range will be used for multicast addressing. This range is explicitly reserved for your multicast addressing. So in this, we take what? We take from the network portion of it 110, first 4 bits. Okay, first 4 bits will be from the first octet, it will be 110. This class E series is basically being used for the experimental purpose, not in use for the IP address, normal IP address assignments. And from this, the first 4 parts will be being used. So it is being used for experimental purpose. This being used for multicast reserve addresses. So we left out with the 3 address ranges for normal IP assignment in case of unicast, right? IP address assignment done from A, B, and C. Let's see an example of let's see an example with classless subnetting, right? So classless subnetting, which gives us the support of VLSM. It supports VLSM, and in classful we don't. For instance, you are assigning, you have these 3 routers connected to each other, right? Like this. Behind this, there is a network. So there are 3 networks, LAN 1, this is LAN 2, this is LAN. So as per this assignment, basically in this LAN, we have what? Behind this router, we have 50 hosts. In this, we have what? Somewhere 30 hosts. And in this, we have what? 20 hosts. Let's do it. We have somewhere 12 hosts. So we have 50 hosts, 30 hosts, and 12 hosts. 3 different LAN networks are there. So if I will go and assign from class C address space using class full, okay, so if I will assign class full, which do not support VLSM, what will happen in this case? I will assign 192.168.1.0/24. So entire range, entire 256 IP addresses will be used by this, even though we have 50 hosts. Same here, if I'll go and use 192.168.2.0/24, entire range 256 assigned to this LAN 3. But we need what? We need 30 hosts. Similarly here, 192.168.3.0/24. Total addresses 256, but we need for 12 hosts. Is this not an inefficient way to assign an IP address to these number of hosts. Think about the real estate developer or think about a chef. In order to assign IP addresses in these three different LAN networks, we need what? We need a efficient way. Who will give us this efficient way? VLSM will give us this efficient way to do it. Using this concept, it will give us a granular approach. It will give us to allocate smaller subnets from a large subnet to each and every one. So everyone basically follows this efficient way to assign IP addresses based on the need. Now, when we will assign address using what? Using classless addressing, doing a method of subnetting, doing subnetting using what? Concept of VLSM. With this VLSM, we will have, let's say we will have a large network 192.168.1.0/24. This is my large network. And then from this large network, VLSM, what VLSM says? VLSM says that break this into smaller subnets. Now how I will break this in smaller subnet? So in order to do that, first you need to understand again from the bit perspective. We have what? We have 8 bits. And if you remember, this first bit is 2 to the power of 7, which gives us 128. This is 2 to the power of 6, which gives us 64. Similarly, we will have 2 to the power of 5, 32, 16, 8, 4, 2, 1. Okay. From this numbers, we will find out our subnet mask. Okay, and the number of hosts. From this numbers, we can find out the number based on the number of host concepts. We will find out which all bits to be turned on based on how many hosts are required. So always we start with the highest number of hosts that has been there. We know that this is our subnet. This is our network, big network. We want to break this into smaller one. First we will do with 50 hosts. For the 50 host, what will be the smaller network? For 50 host, we need to find out in which octet our number falls closer to that. That means this one. 2 to the power of 6 will give us 64. We cannot take 2 to the power of 5 because 2 to the power of 5 will give us 32. We cannot take 2 to the power of 5, right? So that's the reason we take 2 to the power of 6, which will be close to, which will be more than this 50. And also we cannot take 128 as well because it is way more. What is the nearest greater number to number of hosts is what? 2 to the power of 6, which is 64. If 2 to the power of 6 is 64, which is this bit is? This bit is the second bit of it. So the second bit, from the second bit we took the, so how we can convert this? Now we can convert this one as, so what will be the number of hosts that we have? That we are doing with 50, right? Based on this, in which bit basically we got the value of 50, more than 50 is the 2 to the power of 6, the second bit of the octet. The first thing is we need to find out what is the subnet mask. What will be the subnet mask that we can calculate it? The subnet mask, we already know that is what? /24. So /24 is already been there and we were working on this part of it, right? We are working on this part of it to make this subnet /24, CIDR notation /24 more smaller based on what? Based on our requirement. 50 number of hosts that is required for what? LAN 1. We know that which bit gives us that value, close to that value is what? 2 to the power of 6. This is the second bit. So now what we need to do? We need to turn on these 2 bits. Because what? Because we use this bit to get the number of hosts. When we use this bit to get the number of hosts, rest all will be 0. So if you calculate this, what will be my new CIDR number? The new CIDR number is 8, 8, 8 and then 2, which is 24, which was there before, plus 2, which is /26. /26 is my what? Subnet mask. So what will be the subnet mask if I write down in decimal notation? 255.255.255. What is what is it, the value of this one? 128. What is the value of this one? Is 64. 128 plus 64 gives us 192. This will be my subnet mask, represent as /26. What will be how many number of hosts that I can assign? We know that we took what? 6 bits, but even though if you see how many hosts that we can assign, we always do what? 32 is the total number of bits. Which bit that we used? We use 6 bits to get the value as 64, for which is the nearest number to 50, which will gives us what? 26. So 26 is being used for the CIDR part of it. This is our subnet mask. How many hosts that we can assign? It is 6, 2 to the power of 6, which will give us what? 64 value. So now we know that our subnet mask is this. So what is the host that is being configured for this? 2 to the power of 6, which is basically gives us 64. From 64 we will use 50 addresses. Remaining addresses will be used based on what? Based on future thing. So out of 64, one will be the network, other one will be the broadcast address for that LAN 1, and remaining 50 addresses being used for the hosts. This is for LAN 1. If I want to calculate the network, if I want to find out what is the network address for the new network that I created, is 192.168.1.0/26. This is my network address. What is the broadcast address? So we know that what from the start range is 0. We got 2 to the power of 64, which is 192.168.1.63, 64 values. This is my broadcast address. And within this space from 1 to 162 addresses, I can use it for my host. Now this LAN 1 got this network 192.168.1.0/26 is got a new network. From this it will assign. And what is the last IP address? 192.168.1.62. 63 is the broadcast. So this is my last address for this range, which will be assigned to LAN 1. Out of this values, from this values, except the network and the broadcast address, I can assign to all 50 hosts. And one address, any address, you can assign it to the default gateway, which is the router interface which connects to your LAN. Which is the second highest number? The second highest number is 30 hosts. In order to find 30 hosts, what I can do, I need to find out in the octet which one falls greater than 30 and close to 30 as well. So I will select 2 to the power of 5. I will select the third bit for this. I will not select the sixth one because it is 2 ahead of it. So I will use greater than 30, which will be close to 32, right? So I will use 2 to the power of 5. For LAN 3, when I assign, number of hosts is 30 hosts. From a host perspective, we know that 2 to the power of 5 we selected, which gives us 32 addresses. Now in order to calculate the subnet mask for this, we know that we've already been assigned with /24, 1, 2. So we know that we will already have /24, which will be, so this /24 is being there. So what we are using, we were using 2 to the power of 5. 2 to the power of 5 falls in what? Third bit. So we need to turn on the third bit, remaining will be 0. So if we turn the third bit, that means all bit will be 1. we are using this part of it, right, in order to get the number of hosts. So with this 8, 8, 8, 24, 25, 26, 27. What will be my CIDR notation for this /27? Same if I convert this to 255.255.255.128.64. So it's a 128 plus 64 plus 32, which will give us 128 plus 64 is 192. 192 plus 32 is 224. So it will give us 224 as a subnet mask or /27. Now what will be the network address? What will be my network address in this case? 192.168.1.64. Why 64? Because we already been assigned in LAN 1, we already assigned what? 192.168.1.0/24/26 to 192.168.1.63. Till this we assigned to our LAN 1. And we are doing what? Breaking the big network into smaller network. We are doing with VLSM. If we are doing with VLSM, then what will be the next? This one will be the next one. So this is my new network address for LAN 3/27. What is the range from this? Because we are using 32 addresses, 192.168.1.90. So this will be my broadcast address. Out of these, from 65 to 94, you can use it for your host. And one IP from this range, you can give it to your default gateway. Any IP, you can assign it to your default gateway. Which is your default gateway? Default gateway is your interface, which is connected to the router, which facing to the LAN side of it. So now 192.168.1.64/27 will be assigned to LAN 3. We will assign it to LAN 1, LAN 2 now. We'll assign the LAN 1, LAN 2. So LAN 2 network will start from 192.168.1.96. So this will be the network address for this. Okay, so if this is a network address, how we came to know that? After this, so after 95, which has been assigned to LAN 3, so 95, after 95, we will create another network, that is 96. Similar to this, 63, we created here as 64. Similar to that, 95 is the last IP address which is being assigned to LAN 3. So 96 will be the network address here. Now we need what? 12 hosts. 12 hosts will come in which one? It will come in this octet. Greater than 12 is 16 and it is also close to it. So which one is this? 1, 2, 3, 4. So we need to have fourth. We are doing with the fourth octet now. So fourth octet, fourth bit. For LAN 2, total number of hosts is what? 12. How many bits that we need to fulfill this 12 host? We need 4 bits. So we need the 2 to the power of 4 is what? 16. So total number of hosts is -2, host and network, which will gives us 14 hosts, and this will satisfy our requirement. Now we got it from the 4th bit, right? So we know that we have /24 which been assigned. So out of this 88824 has been there. We use 4 bits from the 4th octet. 4th bit is what we used to get 16 hosts. So once you use 4 bit to 16 hosts, 8884, which will gives us 24 plus 4 is /28. So /28 is my CIDR notation for a new network. The network address where we will left with LAN 3 is 192.168.1.95 was left. 96 was the network address. What is the host part of it is 28. From 28, what is the subnet mask is 20/28 CIDR notation. But if we convert this to decimal notation, 255.255.255.128 64 32 224 plus 16 is what? 240. This will be my subnet address. This will the network address with /28. How many host addresses can be assigned? Starting from 96, 16 addresses. So it will come to 111. So 192.168.1.111 will my broadcast address. 96 is my network address. And in that 14 hosts that is left, starting from 97 to 110 will be my host address. Out of this, one you will assign to your default gateway, which will be your router interface facing to your LAN network. So what is the network address? /28 here, right? 192.168.1.96/28. So one address will be assigned to your default gateway. One is your network address. One is your broadcast address. Remaining 13 host addresses you can assign to your hosts. Similarly here, one address to your default gateway for this network. Total number of addresses that is been there is what? 32. Total number of IPs that been there. With that, one network, one broadcast. One is default gateway. Remaining 29 you can assign to the host. To summarize this, basically we got a network of /24. We've used the VLSM concept to create smaller network based on the need of the IP addresses. So LAN 1 we assign 192.168.1.0/26. So from this we got 64 hosts. So out of 64 IP addresses, we will able to assign 62. One is broadcast, one is your network. Same as this one, 192.168.1.64/27 is the network address, 95 is the broadcast address, and then remaining 30 hosts are being used in this. For this one, 192.168.1.96/28 till 111. So this will be my broadcast address. This is the network address. And from this, total number of 16 IP address minus 2, which gives us 14 host addresses. So this is how we created a big network into small networks like 192.168.1.0/26. Another one we created 192.168.1.64/27. And the last one that we created 192.168.1.96/28. Using the VLSM concept, using one big network, we convert that to 3 smaller networks, which makes us a efficient way to assign the IP addresses to based on the need of number of hosts. This is what is called as subnetting.